Hello everyone, today is day 25 of solving a LeetCode problem every day. And today I'm going to be solving add two numbers. So quick disclaimer, I actually haven't attempted this problem yet. I have 0 submissions on this. So let's just go ahead and try to think this through together. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. So first of all, it states that the digits are stored in reverse order. The linked lists represent two non-negative integer, and each node contains a single digit. Cool. So those are pretty much the important points out of that sentence. So if we see these two linked lists right here, I'm assuming this represents 342 and this represents 465. And it says you may assume the two numbers do not contain any leading zeros except the number 0 itself. So what that's basically saying is with these linked lists, it's never gonna, start with a 0. So we have 342. It's not gonna be like 0, then 3, then 4, then 2. It's always just gonna be 342 unless it's a number 0 itself, meaning that we're just given a linked list with just the node 0. So let's see. It says add the two numbers and return the sum as a linked list. So for example, in this case, we have 342 plus 465, and we output a linked list that is 807. In this case, we have 0 and 0. Output is 0 because 0 plus 0 is 0. Cool. So I guess let's try to think this problem through. So I'm going to divide this into subproblems. Like, I guess the first thing we need to do is convert the two linked lists into integers. So what I mean by that is with each of these linked lists, we need to find a way to convert them into their corresponding integers. Like, how do we convert 342 into 342? And how do we convert this linked list into the number 465? So I guess that would be like our first concern. And then our second concern would be actually adding these numbers together and outputting a new linked list. Like, adding them together is going to be the easy part, but we have to create a new linked list out of whatever this output is. So, well, for starters, to convert these two linked lists into integers, we have to be able to traverse the linked lists. So the first question we got to ask ourselves is how can we traverse these linked lists? So we have L1 and L2. So I mean, the easiest way to do that is by having a pointer. So we can have, let's see, L1, let's call it L1 current is equal to L1, and L2 current is equal to L2. So basically what we're doing here is we're creating pointers that we're going to use to traverse these two lists. So L2 current is for the L2 list, and L1 current is for the L1 list. Now let's see. I guess another thing we have to account for is the fact that in this explanation, it doesn't tell us that these linked lists are always going to be of equal length. Like, for example, we might be given something like 2, 4, 3, but then our second linked list might be like 5, 6 only. So that means that we probably have to traverse these two linked lists separately just because, or find a way. Yeah, we basically have to find a way to do this separately because, we're gonna go out of bounds if, we go 3 numbers to the right here. If we go 3 numbers to the right here, there's just gonna be none here. But I guess for now, let's just kind of start the implementation. So we have while L1 current, we just want to say L1 current is equal to L1 current dot next. What this is going to do is just this traverses the entirety of list 1, and we can say the same thing for list 2. So we can say list 2 current is equal to list 2 current dot next. And if we just print out the values here, so dot value. We say print L2 current dot value, and let me also return something. I'm just gonna return none, just so we can see what's going on here. So over here we have 243, so we have 243 here, and we have 564. So step one is pretty much done. We figured out how we can traverse these two linked lists. We're just doing that with while loops. Now I guess question number 2 becomes, how can we actually convert these values into the integers? So I guess the one thing we can do is, what if we stored these in strings, right? So if we have 243 and 564 as the outputs of these traversals, so we can store 243 into a string. So basically we start out by adding 2 to the string, started by adding 4 to the string, then next we add 3 to the string. Then what we can do is reverse the string and then cast it into an integer, which would give us 2 integers. So we can do that by saying, we can say L1 string is equal to just that, and then L2 string is equal to this. And then each iteration, we can just be like L1 string plus equals L1 current dot val. Same thing here. L2 current dot value. Now I'm gonna run this again just because let's see what our outputs are now. And I want to make sure that we don't get an error from this right here, because these are currently, I'm assuming, stored as integers, and I want to make sure that Python automatically converts it for us. So let's see. It says can only concatenate string, not integer to string. So now we know we gotta cast these to integers. So let's do that. So now if we run this, it should print out the 2 strings. Oh, none and none. Now why is that the case? Oh, it's because printing out the wrong things. So this should give us the strings now. So we have 243 and 563. Now all we gotta do is reverse these. Now let's see if string, I'm assuming there's no reverse method, but there must be some method in Python that allows us to reverse a string. Let's see, we can just look this up real quick, like how to reverse a string in Python. Okay, so it says there is no built-in function to reverse a string in Python. So let's define our own function. So we can do this over here. We can say def reverse string. So we're defining a function called reverse string. This function is going to take in a string. We can just call this string. Oh, that's revert. Let's call this S. And then let's see. So we pass in S. So now let's think about this. How can we reverse a string? Well, one thing we can do is have an output. Our output's going to be an empty string to start. Then what we can do is traverse these 2 strings in reverse order, and then just add them to the output like that. So I believe that would be something like for I in range of length of S. So let me think about how to do this again. So we want to start at the length of S. We probably want to end at 0. It might be like this. Let's, again, sometimes if you're not sure, you just have to print stuff out and figure it out like that. But let's say print S. I don't know if you can do that in Python either. So, let's try that for now. We can just say here, oh, this also has to have self here, but we can say self dot reverse string, and let's pass in L1 string and see what happens. So we run this, and it says string index out of range. So probably have to subtract this by 1. Okay, and now as we can see, it's printing out our string. So the problem here is length of string is going to give you an index out of bounds error, because we're starting 1 above the max index of whatever the string is, because remember, stuff starts at, stuff is 0 index, it starts at a 0, so we got to keep that in mind. And then we say here we want to end at 0, so we put in -1 because it's always going to end the number, I guess, before this. And I think -1 is just our step, which is we're stepping -1 each time, so we're going backwards. So anyways, now we're going backwards. We had 2 4 3, but we're instead changing it to 3 4 2. And what we can do, just say output plus equals SI. And then we can just, at this point, return output. So if we say self.reverse string L1 string, reversed L1 string is equal to self.reverse. And then if we print this out, we can see that we have 3 4 2, which is the reverse of this. Cool. But what we also know is we want these in integer format. So let's also cast these to be integer. And if I print this again, this should, I mean, it doesn't show that it's an integer, but it's an integer now. Cool. So we do the same thing again. Let's call it, it's not a string anymore, so I'm just gonna call it reversed L1, and then reverse L2 is equal to int self.reverse string, let's see, L2 string. Cool. And then we want our total, so we're gonna say reversed L1 plus reversed L2, because this is gonna give us the total that we need. Yeah, so for example, like whatever this, so this will give us 807 in this case. So if I print out total for this specific test case, which matches this test case right here, we should get 807. So cool. Let's remove these print statements. Let's also remove this print statement right here. So let's also remove these comments, since I think we have a pretty good idea of what we're doing now. What is our next step now? So we have our total. So our next step is actually creating these linked lists. So I guess one thing I also have to ask myself is, in this output, each of these are going to be a node, and each node has a value, and the value is going to be 8 in this case, a value of 0, and a value of 7. I'm going to assume that it wants me to store these values as integers. So one thing that we have to remember is that when we do create these linked lists, when we do create this linked list, we got to make sure that these values are in integer form and not string form. Because, we could have them stored like this, but I think they want them as actual integers. I think that would not be correct. But anyways, so we have our total now. So what I'm going to do is the same thing again. I'm going to say total string is equal to string total. And the reason why I'm doing this is the idea is we have our total of 807 now, but we want to store it as 708. So we probably want to reverse this again. Let's see. So we convert, let's do total reverse string is going to be, we're going to cast it to a string, and then we're going to reverse it. And then let's print this again just to make sure we're going in the right direction. So if I run this, oops, self.reverse string. So let's run that. And we have 708 here, which is what we're looking for. And now the idea is just to create the new linked list. So let me just separate all this a little. We don't need this anymore. But let's start out with creating a dummy node. And this is just going to be the very first node. I mean, it's not going to be the very first node, but it's going to be like, you can assume it to be like before the head. I'm just going to make this -1 actually. And then we're going to say for I in total reverse string. So now what we're doing is we're gonna traverse through each and every character in reverse string, and then what we're gonna do is just create a new node and set the next node. We're also gonna have like yeah, so we're gonna do it like this, and we're just gonna pretty much create this list now. So we're gonna grab the character, create a new node, and then we can set it to be the current node. Or this might not be right. Let's say current is equal to dummy. So we want current.next to be the new node. So anyways, it's gonna be like new node is equal to node, and this node is gonna have a value of, we're gonna cast it to an integer, and it's gonna be I. So whatever the current character is, but in integer form. And then we're just gonna say current.next is equal to new node, and then current is equal to current.next. And now I believe this should give us the new linked list. So let's see. So now we know dummy.next is gonna be, so let's just return dummy.next. And let's see what happens when we run this. Node is not defined. It's called list node. And there's probably going to be a couple more things that we have to figure out, but I just want to first make sure that this code runs. Okay, so it seems like we've already gotten accepted for all the test cases. Let's try submitting this. I guess, okay, you're given 2 non-empty linked lists. One thing I was going to think about is, what if we're given an empty linked list? I didn't really account for that. I don't know if I accounted for that in the code, but it says you're given 2 empty linked lists, so it doesn't matter. So if I submit this, we got accepted. Cool. So the current time complexity of the solution is going to be O of n. And we can see that because so we have no nested for loops, first of all. So here we're just traversing n amount of times for like whatever. So if the input size, or if the length of L1 was n, we're traversing n times. Same thing with here. Let's give it a different variable, maybe j. If the length of L2 was j, we're traversing j times here. And then reversing these strings is also going to be a linear time operation, because we're just looping through each character in the string once. So that's going to be n times or whatever. We're doing that n times, again, n times here. And then this is going to be another whatever the length of this going to, so, and it's going to be linear. It's going to be in linear time again. So basically what the point I'm trying to make is, every single thing that we're doing here is, it takes linear time to do based on whatever the input size is. But as for space complexity, let's see. So we're storing the length. So we're creating a string out of whatever the length of each linked list is. So we have to store that. And then again, the same thing here. We're storing a string for whatever the length of L2 is. And then let's see, what else? It's going to be the same thing. It's going to be linear again. And the reason why is, like, at most, we're going to be using, like, it's going to take a linear amount of space. And the reason why is because for each of these operations, or not operations, but whenever we're storing the string or whatever, it's always going to be based off whatever the length of L1 and L2 is. So we can assume that it's going to, like, as L1 and L2 increase, the amount of space that we're going to need is just going to increase linearly, since it's directly proportional to whatever the length of L1 and L2 is. So yeah, the space complexity is going to be linear also. And yeah, so I mean, let's see if there's any finishing touches I'd like to add to my solution. Yeah, I don't really know what I'd do if it's off the top of my head right now. I don't want to make this video too long, but I mean, I could definitely look through the code, and you know, there might be like little optimizations that can be made. But this is the general idea behind how I'd solve this problem. And yeah, I hope this was helpful.